Hello, I'm Brian Shu, and this is my presentation on industrial lighting. It's a pretty big topic, so I'm going to kind of narrow it down to my own experiences doing lighting at McKinley Paper, the kinds of fixtures we use, the kind of bulbs we use, our recent LED upgrades, color temperature, different circuit voltages. These are just some things I'll cover. First, I'm going to start about the different types of lighting fixtures we have around the mill. High bay lighting refers to the powerful lights designed for spaces with high ceilings, typically 20 feet or taller, and are common in industrial and commercial settings like warehouses, factories, gymnasiums. These fixtures are used a narrow beam of high lumen count to concentrate light, ensuring adequate and uniform illumination across large areas without glare, which is usually crucial for safety and productivity. Next obvious choice is low bay. Low bay lights refer to lights fixtures that are designed for spaces with ceilings between 12 and 20 feet, such as retail stores, garages, workshops. These lights are designed to spread light widely and evenly across the large floor, reduce glare and shadows. Wall pack lighting refers to durable exterior grade fixtures mounted on a wall to illuminate surrounding areas, commonly used for security, safety, and ambience. These lights direct light downward and outward to brighten walkways, building entrances, parking lots, and other outdoor spaces. They are built to be weather resistant and are available in various types, with LED packs being popular now due to their energy efficiency and longevity. Explosion proof lighting is, I just skipped ahead. Trofer lighting refers to a recessed lighting fixture, typically rectangular. It is designed to fit into drop ceilings, grids, provide uniform ambient illumination. The name is a blend of trough and coffer, described in a shallow trough-like space. These fixtures are commonly used in house fluorescent, more recently LED conversions for offices, schools, retail stores. Explosion-proof lighting is a type of lighting designed for hazardous environments in which flammable gases, vapors, or dust are present. These fixtures are built to prevent an internal spark or electrical event from igniting the surrounding atmosphere. Key features include robust sealed enclosures to contain any sparks, durable materials to withstand harsh conditions, and specialized design elements like thick lenses, precision machine joints that cool hot gases. Floodlighting is a type of broad-beamed, high-intensity artificial light used to illuminate large outdoor spaces. Vapor-tight lighting refers to fixtures that are sealed and gasketed to prevent the entry of moisture, dust, and other contaminants, making them suitable for harsh and wet environments like car washes, food processing plants, and industrial areas. Unlike standard lighting, they're durable construction, often with materials like polycarbonate or reinforced fiberglass or robust seals. The internal components from environmental damage and ensure reliability and safety. Alright, now that we got the fixtures down, let's look at the kind of bulbs we use around my mill. HID light stands for high intensity discharge and refers to lighting that produces a bright light by passing an electric arc through a gas filled chamber. This method is more efficient than traditional incandescent bulbs and is used in applications like street lights and industrial settings. Typically in our mill we got the 1000 watt that you're looking at. We also have 400 watts. HIDs are significantly brighter than halogen bulbs and provide whiter, more daylight color. They are more energy efficient than incandescent and halogen lights, consuming less power and higher light output. Lifespan of HID bulbs have a longer lifespan than traditional bulbs, though they do degrade over time. There's three main types that we use in our mill of HID bulbs. We got the high pressure sodium, metal halide, and mercury vapor. Incandescent light. It's a pretty classic bulb there. We don't have a ton of applications for them anymore. We've upgraded to LEDs, but we do have a few places they are needed. Incandescent is produced by heating a wire filament with an electric current until it glows, a process called incandescence. The filament is enclosed in a glass bulb that either a vacuum or filled with an inert gas to prevent oxidation. This classic type of light bulb is known for its low initial cost and warm yellow-white light, but it is energy inefficient, converting most of the energy into heat rather than light. We do have a handful of fluorescents in the mill. A fluorescent light is a type of gas discharge lamp that uses electricity to excite mercury vapor, producing ultraviolet light. This UV light then strikes a phosphor coating on the inside of the glass tube, causing a phosphor to glow and emit visible light. The process makes fluorescent lights more energy efficient, long lasting than incandescents. But one thing we've been updating these old incandescent bulbs with is the LED variety. An LED light emitting diode is a semiconductor device that produces light when an electrical current passes through it. LEDs are known for their energy efficient, long lasting, and directional, which makes them popular alternative to traditional incandescence and fluorescence. How they work is an LED is a type of diode, a two-terminal electric component that conducts current primarily in one direction. It is made of a semiconductor material that has been doped to create negative N-type and positive P-type. When the current flows through the anode to the cathode, electrons and holes combine, releasing energy in the form of photons, which creates light. The color of the light depends on the specific semiconductor material used. To produce white light, LEDs combine different colored LEDs and use phosphor coating to prevent the light from becoming a blue LED. Alright, so when we need to choose new lighting fixtures or we're going to replace the old ones, there's certain things we need to take into consideration. One thing is choosing a color temperature. Depending on the application, you get a different kind of color temperature. Usually on the lower on the warm light, about 3000 K, break rooms, relaxation areas, spaces where comfort is prioritized. But if you want to move up into the 4K, 3500 to 4K, you're going to be looking more like general office spaces, warehouses, and multi-purpose rooms. Now we're going to go up to 4 to 5000. It's a bright, crisp white light that promotes alertness. General industry applications, manufacturing, and assembly lines. And if you're going to go and past the 5,000 up to 6,500, you're going to find yourself into high precision tasks, quality control, and inspection areas. These nice white lights are good for alertness and safety, generally. I'm running low on time here, so I'm just going to keep banging away. Alright, when you're looking at changing lighting, you want to know your circuit voltage. The most common voltage in residential is about 120. Commercial, industrial, especially in my mill, is usually around 277, 208, 120, even 480 in some places. example of color, temperature, and lumens on an LED fixture. Looking at efficiency of different types of bulbs, which is going to bring us to LEDs, which I'm going to quickly gloss over because I ran out of time. LEDs are highly efficient. You get HVAC savings. The minimal heat emission from LEDs reduces demand on cooling systems. A lot of smart controls with dimmers, daylight harvesting systems, energy savings, maintenance cost reductions, extended lifespans of some bulbs up to 50 to 100,000 hours. Reduced labor and frequent replacements is always a good thing. Durability. LEDs are solid state, so they're resistant to shock and vibration. Temperature fluctuations. Some additional benefits of LEDs, also safety and productivity. They got that nice white light, alertness. There's always rebates and incentives, and environmental impact. There's no harmful mercuries in these bulbs like others, or other hazardous materials. And to wrap it up, we talked about, I think the main goal of this presentation is that everybody should convert to LEDs in any way you can. Most of the other bulbs I talked about are obsolete now, except for some very niche applications. Thank you for listening.